Okay, we are on page 60 and we're going to go over lesson 1.7, compute with scientific notation. So if you are not there in your book, go ahead and pause the video and open up your book. Okay, we're going to look at problems now that involve scientific notation and problems that are multiplying and dividing. How do we multiply and divide scientific notation? So let's take a look at this first one. It says evaluate 7.2 times 10 to the third times 1.6 times 10 to the fourth. Express the result in scientific notation. So because this is a multiplying problem, we are going to multiply 7.2 times 1.6. We're going to multiply the numbers in front, and then we're going to add the exponents on the base 10s, because that's the rule for multiplying the same base. They're both 10s, so we're going to add those. Okay, so we're going to grab a calculator and multiply these two, and you will get 11.52. We're going to write times 10 to the, now we're going to add the exponents. 3 plus 4 equals 7, so that's going to be 7. So this kind of looks like scientific notation, except this number, remember this factor in front, has to be 1 or more but less than 10. So right now it's 11.52. So we need to actually move the decimal over and make this number between 1 and 10. So I'm going to move this decimal one place to the left and stop it right there. If I stop it there, now my new number is 1.152, and that's between 1 and 10. But I have to account for that one move in the decimal. So because I moved left once, I'm going to add 1 to my exponent. So our final answer is 1.152 times 10 to the 8th. That is in scientific notation, and that's what it asks for on this problem. Okay, let's try another one of those. We have, let's look at the got it problem, and you do this with me in your book. So we have another multiplying problem. So remember, we're going to take the two numbers in front, 8.4 times 2.5. Grab your calculators and multiply those. And then we're going to add the exponents because these are the same base, and that's the rule when you multiply the same base. Okay, so when you multiply these two numbers, you get 21. Then we're going to write times 10. We keep the base of 10 and add 2 plus 6 is 8. So right now this is almost scientific notation, except remember, this number has to be between 1 and 10. 1 or more, but less than 10. Right now it's 21. So we're going to move the decimal. The decimal right now in this number is at the end. So if we move this decimal one place to the left and stop it right there, now our new number is 2.1. And we're going to write times 10 to the, remember, if we move the decimal, we have to account for that move in our exponents. So because we moved 1 left, we're going to add 1. So 8 plus 1 would be 9. That is our final answer in scientific notation. Okay, let's just take a look at one more. This one is another multiplying problem. So we're going to take 2.63 times 1.2, and when you do that on your calculator, you actually get 3.156. And then remember, we're going to add the exponents on the base of 10. So we have 4 plus a negative 3. 4 plus a negative 3. And that actually equals 1. You're going to subtract those two numbers and use the sign of the bigger number. So final answer, 3.156 times 10 to the 1. We didn't have to actually move this decimal because this number was already 1 or more but less than 10. So that is our final answer. Okay, let's take a look at dividing the same base. Take a look at dividing the same base. We have this word problem, so let's read this first. Okay, so in 2010, the world population was about 6,680,000,000. The population of the United States was about 3 times 10 to the 8th. About how many times larger is the world population than the population of the United States? Okay, so because it's worded like this, about how many times larger, we're going to set up a division problem. So we're going to take the world population and divide it by the U.S. population. So now the world population is 6,780,000,000. or 860 million. So we're going to estimate that number. We're actually going to round that. 6,860,000,000 is about 7 billion. So let's just round up and make it a little bit easier to deal with. Divided by, the United States is 3 times 10 to the 8th. Well, we now have two different types of numbers. So what we're going to do is we're going to take this number that's in standard form, a regular number, and we're going to turn it into scientific notation like this one. So we're going to take the decimal at the end, and we're going to count how many times it takes us to move this to make this number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to stop it right there because then my number is 7. I don't need the rest of the zeros. Times 10 to the 9th, because it took me 9 times to move it, and now divide it by 3 times 10 to the 8th. Okay, so now we have a division problem. So the rule for dividing scientific notation is you're going to divide these factors in front and subtract the exponents. So we're dividing the same base, you're going to subtract the exponents. Okay, so when we grab our calculator and divide, 7 divided by 3 is 2.3. We're just going to round it off to 2.3. Then we're going to write times 10 to the 9 take away 8 is 1. And because this was actually asking for a standard number about how many times larger is the world population than the population of the United States, we're going to solve this final. We're not going to leave it in standard form. We're going to solve it and get a number that we can relate to better. So because our exponent is a positive 1, you're going to move this decimal 1 to the right. So if we move the decimal 1 to the right, our number is now 23, and that is our answer. The world population is 23 times bigger than the United States. Okay, and let's just try that one more time. We're going to look at this problem at the top of page 61. One more of these. So we have the surface area of Lake Superior, the largest of the Great Lakes, is 8.10 to the 4th square kilometers. The surface area of the smallest Great Lake, Ontario, is 18,160 square kilometers. About how many times as great, okay, that's worded the same way as the one we just did, is the area covered by Lake Superior than Lake Ontario. Okay, so we're going to put Lake Superior and divide it by Lake Ontario. So Lake Superior is 8 times 10 to the 4th. Lake Ontario is 18,160. So remember, we can't divide until these are both either standard form or scientific notation. So let's turn this into scientific notation. We're going to keep 8 times 10 to the 4th on top, and we're going to change this number, and we're actually going to estimate this number first. Let's round it and make it a little bit easier to work with. So 18,160 is about 20,000. Let's